All right, so let me give you a little bit of an idea where this paper comes from. Following the financial crisis, there was an explosion in the number of papers written that were proposing systemic risk measures. So a pretty interesting survey came out around 2011 by Andy Loans and co-authors. And they had a list of 30 systemic risk measures that have been published since basically 2008. And I'll tell you that 30 systemic risk measures doesn't even sort of, that's the tip of the iceberg basically. Those were the ones that they could kind of put together in, you know, a form where they had a way of describing what exactly the measures were and a way of sort of thinking about how you can build these measures from data. There have been many more proposed since then. All of them sort of have this flavor where we say, all right, in 2008 we saw this big spike in risk in the financial sector. We want to think of it as stress in the system and maybe it has some bad consequences, but it's really hard to evaluate what these things mean. And that's what we're going to try to do here. There hasn't been sort of a broad empirical quantification of how systemic risk actually influences things that we might care about. That's kind of the big picture idea of what we'll go through here. Okay, so each of these measures, they're sort of explored separately and they're all evaluated separately. So one thing we want to do is we want to take a broad sort of global evaluation of all of the measures that have been put together. Another thing that we're going to do is most of these measures, when they're presented about the recent financial crisis. So we want to take those measures and build them backwards. Again, give us a broader view on how these things have performed, not only in the recent crisis, but in other times of stress in US and even European history. Most of them are applied to the US. We're going to build them also for the UK and EU. Now, one thing that pops out right away is it's not really clear what these different systemic risk measures are capturing. They all sort of have a different motivation behind them and a different flavor. And it sort of makes you feel like, at the very least, systemic risk kind of has to be a multifaceted object. We're going to try and put this together in a way that might be useful from sort of a policymaker or a regulator standpoint. So first of all, we want to get a little bit of a better idea of what is systemic risk. We're going to try and take some steps to better measure and detect systemic risk. And the main thrust of our paper is to think about welfare. Why do we care about systemic risk from a policy standpoint? I can think of lots of reasons why we care about systemic risk, say from a financial market standpoint. But if that just affects market participants and never spills over to the real economy or consumption of households, is it something that regulators or policymakers should be spending a lot of time thinking about? Maybe it should be something that just should be confined to the way people are thinking about the functioning of markets. All right, so we're going to try and make a statement about how sort of welfare relevant these systemic risk measures end up being. So that's going to be what we think of as the first contribution to the paper, is to just state a specific criterion for how we might evaluate systemic risk. If it turns out that we can detect a spillover of systemic risk measured in terms of financial sector stress into things that we care about, say for households, consumption growth, productivity growth, etc., then that's something that we think policymakers should be paying close attention to. If not, it may be the case that this stuff is isolated to financial markets. It's financial market participants that need to be caring about this, so then we don't necessarily need to think about, you know, policy that's designed to, say, protect households from upticks in systemic risk. The way we're going to quantify this is we're going to look throughout the distribution of macroeconomic outcomes, and I'll talk a lot more about that in detail as I go. Okay, so first, to give you kind of a big overview of how these measures move, they don't move together very strongly at all. So of the 17 or 20 measures that we put together, the average correlation is pretty close to zero on average, which may not be surprising. Systemic risk is probably a really hard thing to measure, so when we do put these measures together, they're probably quite noisy. And that might be part of the reason why we wouldn't get a whole lot of information out of them. So that's one thing I want to do, is just point out that it looks like these things are capturing either A, very different things, or they're just very noisily measured. And I'm going to ask a question about how we might get past things like measurement issues to make some use of systemic risk measures. So to solve that problem, we're going to introduce some dimension reduction techniques. So if you think about the way the macro literature has proceeded in terms of all of their attempts to forecast future macroeconomic outcomes, think of the Stock and Watson style literature. What they do is they take a huge number of macroeconomic time series and try and condense it down to a small number of predictive indices. The idea is very similar to the systemic risk setting. Individual measures have a lot of different things going on, and they have different measurement issues that they're facing. But if we can aggregate them in some efficient way, we might be able to isolate the useful, the informative component of each of these measures. And we're going to apply that rationale to the systemic risk setting. So we're going to propose a couple of dimension reduction techniques, and we're going to see, after we do this, do we now find some sort of detectable relationship between the macroeconomy and systemic risk? We're going to end up with a positive conclusion here. All right, and the last objective is to just give the literature a set of empirical stylized facts to work off of in terms of thinking about systemic risk and the macroeconomy, as opposed to just systemic risk and the financial sector or financial markets. Okay, so here are the stylized facts that we come up with. Because we're going to look around the distribution, the entire distribution, not just the mean or the median, I'm going to look at the entire distribution of macroeconomic outcomes. Think of things like consumption growth or industrial production growth. I want to look at the distribution of this and how the distribution relates to different levels of systemic risk. And what we find is really interesting. It's just the lower tail of the macroeconomic outcome distribution that seems associated with systemic risk. If you do, for example, a mean forecast, you try and forecast average production growth, so your typical OLS style forecast, you don't see anything there. Which turns out to not be so surprising if you think about the way the theoretical literature has proceeded in modeling systemic risk. What most of that literature concludes is that you have these very highly nonlinear effects in how stress in the financial sector might spill over to the macroeconomy. One other interesting conclusion that we find is that of all of these measures that are proposed, some of them get very complicated. The one that works most reliably well is just a simple measure of financial sector equity volatility. And then lastly, we're going to look at not only macroeconomic outcomes, but the behavior of policymakers as well. If you think that there might be a connection between systemic risk and the macroeconomy, you might also think you could detect what policymakers are trying to do to stem systemic risk. And so we look at things like changes in the federal funds rate, and we see that our systemic risk measures do correlate with that. In fact, they correlate again with the lower tail of the Fed funds rate. When things get really bad and the Fed funds rate gets dropped a lot, that's where we start to detect this relationship between systemic risk and policymaker behavior. All right, so that's kind of the big picture view of what we're going to do. If I were to summarize our results, it would be this. We do find a positive association between systemic risk and economic activity. All right, so I think this is a positive statement about everything that's been happening in the systemic risk literature. It takes a little bit of, we have to be a little bit of nuance in terms of how we think about measuring the systemic risk. But if we're careful, if we take into account the idea that there's probably a lot of measurement error in these different measures, if we're careful about how we aggregate the information, we do identify that this is something worth trying to measure, and it's probably something that's going to be useful for policymakers to work off of. All right, so the increase in systemic risk has some impact, but it turns out to just be on the left tail of the economic activity distribution. And to give you a sense of magnitude, let's think about the 20th percentile of, say, industrial production growth shocks. So something that's close to a tail event, all right? Unconditionally, the 20th percentile of the IP growth distribution is about minus 1.4% per quarter. If you condition on one of the systemic risk indices that we're going to build, we're going to find that it drops to about minus 2.2% per quarter, all right? So when we enter times that are one standard deviation higher in terms of the level of systemic risk, the downside portion of the distribution becomes effectively more skewed. The center of the distribution hardly moves, but the downside distribution stretches out. And you'll see I'm going to be talking a lot about quantile regression today, and the reason why is it's going to allow us to understand effects of systemic risk on these different parts of the distribution, in particular on the lower tail of the distribution. But this, in some ways, understates the effect of systemic risk on the macroeconomy. Because when we enter a crisis, it's really not a one standard deviation uptick in systemic risk. It's usually like 3, 4, 5, 6 standard deviations. So we see that when we enter crises, the 20th percentile of the IP growth distribution is almost always below at least minus 3% per quarter. Okay, so we're talking about huge economic importance here. And then when we look at trying to predict policy reactions, the 20th percentile of changes in the Fed funds rate also drops a lot. So unconditionally, the 20th percentile is about minus 50 basis points. When bad things happen, we drop the Fed funds rate about 50 basis points. Conditional on a 1 standard deviation increase in systemic risk, that goes further down to about 80 basis points.
Clarification about those magnitudes. That's 3% per quarter on an annualized basis?
So this is, no, these are trend deviations, quarterly trend deviations.
So there's massive.
These are massive effects, yeah. Okay, so I want to give you just kind of an overview of what the landscape of systemic risk measures is. These are going to be the systemic risk measures that we largely take from this Andy Lowe survey and that we build. Okay. So the Andy Lowe survey is qualitative in nature. So it basically lists the measure, describes them, describes what they're trying to do and what their motivation are. We take those and we build each of them, and we build them back as far as we can with data. Of course, data limitations are going to be very relevant here. Most of the measures that we can build are going to be the measures that are based on some sort of market data. Okay. So if you can think about measures that are based on the market equity of banks, public banks in particular, that's going to be the stuff that we can build. So they propose 30 measures, we end up building about 19 of them. And we've broken them down into a couple different categories. So first we have some institution-specific measures. So the ones we have in mind are things like COVAR, which comes in a couple of different forms, and systemic or marginal expected shortfall. So these are a couple different folks at NYU have proposed some of these measures. Then we have measures that we consider co-movement and contagion measures. So something like the absorption ratio, which is about effectively how strong the co-movement is among the big panel of equity returns for banks in the US. The dynamic causality index, which is a measure that tries to get at, all right, if one bank experiences a big shock in its equity value, how does that transmit subsequently to other banks? And then we have this international spillover index from Frank Diebold, where they're looking at some of this contagion experience across borders as opposed to just across banks. Then we also have measures of liquidity and credit. So we'll look at an aggregate version of the Amahud illiquidity measure. We'll measure illiquidity bank by bank. We'll aggregate that into an index that we'll just call AIM. We'll look at the TED spread, the default spread, and term spread to get a sense of stress in credit markets. Lastly, we have these measures of what I'll call instability or volatility. And these are sort of the measures that we're going to get the most mileage out of in our empirical work. One thing we can do is just calculate the volatility, the equity volatility of the financial sector portfolio. That's going to be one of the most useful measures we can look at. A very closely related measure that's been proposed is called turbulence. You can think of it as just another measure of volatility that also adjusts for the extent of correlation among banks. Then we have leverage measures. We could look at book leverage, so just assets to debt, for example. We could look at market leverage, so we'll look at something like assets to the market value of equity as opposed to a book value of equity. And then we'll also look at size concentration. You might think when we have a financial sector that gets very concentrated in terms of assets mostly being in one bank, that could be a potentially more unstable situation. So we'll give that some possibility as well. Now, some stuff that we don't cover, and I think Fernando will probably at least allude to this in some of his discussion because he's worked on it. We don't get to talk about direct linkages at all. What we would love to have when we're thinking about systemic risk is some notion of exposures that banks have to each other. Something like a network topology of the financial sector. Things like repo exposures among banks. That would be great. We don't have a lot of data for that. And even if we did have the data, we don't have a lot of time series to work with. So we're going to be working with quarterly macroeconomic outcomes. So I have to have series where I can build effectively a fairly long time series. So we're not going to be able to do that, and related, we're not going to be able to look at things like CDS-based measures. CDS-based measures would be fantastic to use, but at the very best we have data effectively starting in 2001. Now we're going to construct each of these measures separately for the US and for the UK, and then we're going to build a version that we call the Euro area version. So that includes all financial institutions in Germany, France, Spain, and Italy. This is just kind of to give you a quick peek at what some of the measures we build look like. So on top we have the default spread, dynamic causality index, market leverage, financial volatility, TED spread, and turbulence. So one thing you'll notice in common from all of these predictors is that they have huge spikes during the financial crisis. That's not surprising. Each of these measures was proposed to give a description of the stress that we saw in the financial sector during the crisis. What's interesting is when you go back before the crisis, and you see back before the crisis, these things have very different behavior a lot of the time. You get things like systemic risk looks high in the expansion that was characterized by the tech boom. Do we want to think of that as a measure of systemic risk, or just the fact that we had an economy during that episode that had high volatility because there was a lot of new innovation, for example? That's probably something that's more like a false positive when we're measuring systemic risk. So these are types of things that I think of as contributing to noise when we're trying to quantify systemic risk. And it's possible that by sort of combining all of these things in a clever way, we can improve our measurement of the thing that we actually care about, that portion of stress that we think should be at least common to all of these. Okay, so as I mentioned, it looks like all spiked during the crisis. Correlations are typically low on average. And we also look at the dynamics among the measures. Are there some measures that sort of tend to precede the others? That is, do we have leading systemic risk indicators and coincident or lagging systemic risk indicators? And that's certainly the case. Some of the best leading indicators are credit spreads and volatility, and also covert does a very, very good job. But the extent that these things are actually useful for measuring macroeconomic outcomes is not clear from thinking about this. Because when we're looking at leading measures, we're trying to understand, does a spike in systemic risk measured by one variable today predict systemic risk measured by another variable? That's sort of like just trying to predict another sort of outcome in the financial market. So we're going to want to go beyond that and look at, for instance, some predictive ability in the macroeconomy. All right, so possible things that could be going on. One thing that can be going on that leads to all this heterogeneity is that measures are noisy. Another thing that could be going on is that there are a lot of different dimensions of systemic risk, and that would lead these things to have relatively low correlations. And another thing that could be going on is that sometimes these measures capture stress in the financial system, but that's not stuff that ends up spilling over into the macroeconomy. Why might systemic risk not spill over into the macroeconomy? Well, it's something that's just really relevant to market participants, could be one thing. Another thing is that you could have a situation in which policymakers respond, and the response works. So they watch the financial market, they see it looks like things are heating up, they take some steps to cool down the economy, and we never see it manifested in real outcomes. We never see it manifested in long term. All right, so let me go into a little bit more detail about this criterion that I've been referring to and tell you how we're going to think about measuring it. So the motivation for this is based on a fairly small but growing literature that tries to theoretically understand how stress in the financial system can spill over into the macroeconomy. So kind of the fundamental basis for this would be something like a financial accelerator model. This was really first formalized in kind of this nonlinear relationship by Kiyotaki and Moore. The idea that when systemic risk goes up, most of the time, you aren't going to see much happening in the macroeconomy. But if it goes up high enough, we can reach a tipping point. And then the effect on the macroeconomy can accelerate really quickly. So they emphasize this nonlinear relationship between systemic risk and the macroeconomy. And that's also been really the defining feature of the more recent versions of models, things like Brunermeyer, Sanikoff, and Sahini Krishnamurthy. So we're going to take this nonlinearity seriously. We're going to keep in mind that it's very likely that most of the time systemic risk isn't moving around the distribution very much. But if systemic risk gets high enough, it can have severe consequences. If we think about what that means for the conditional distribution of macroeconomic outcomes, it's probably going to be something like the tail of the macroeconomic distribution seems related to systemic risk, but not the central part of the distribution. It might be more difficult to see things by looking at things like median or mean forecasts. And then to put this in context of where we think our paper stands in the literature, there's been a lot of progress on the theoretical, and this is one situation in which the theory seems to be quite a bit ahead of the measurement. So we have some idea about this link between systemic risk and the macroeconomy from a theory standpoint, and we want to fill it out with kind of a big picture overview of what the empirical landscape looks like. So that's where we think of our paper fitting in. All right, so the criterion. This is just our point of view. You may disagree with it, but our point of view is that if policymakers are going to be paying attention to systemic risk measures, They should do it because they think it affects welfare. If it's something that's just about stress in the financial system that never translates into welfare, it's not clear that policymakers should be doing anything about that. So our point of view, you may disagree. I'll be curious to hear your disagreements. But what I want to do is that if this is the criterion, can we actually validate that systemic risk does have such an influence on welfare? So we think of this criterion as being useful to start a conversation and to help us guide this empirical evidence that we're trying to establish. All right, so how are we going to operationalize this? We're going to rely heavily on this idea that it looks like there can be a nonlinear relationship here. This is what's going to drive us to look at quantile regression as a way of quantifying how systemic risk affects economic outcomes. All right, so if I think that it's just the case that, say, systemic risk could affect the center of the distribution, or would just be sort of a shifter of the distribution, then OLS would be sufficient. I could sort of look at the conditional mean effect, conditioning on systemic risk as a regressor, and that would get me where I need to go. But if, say, the He and Krishnamurthy model is right, this is actually a really poor way to detect what's going to be going on between systemic risk and the macroeconomy. I'll be very likely to not see anything there, because all of the action would be in the lower tail, but the center of the distribution wouldn't be shifted at all. You think about the distribution here, that center is more or less fixed, and what systemic risk does is stretch mass further down to the left. All right. So one thing that's nice about this is that it's a reduced form way to get at this nonlinear impact. All right, so a very quick overview of how quantile regression works. What we do is we have some target variable. We're going to call this yt plus 1. Think about it as industrial production growth 1 quarter ahead. And we're trying to describe a particular quantile of this distribution. It could be the median. It could be the lower 10th percentile, the upper 90th percentile, etc. And I'm going to make that a linear function of some explanatory variable. So these are going to be xt here. Xt will be our systemic risk measures. And this can be a multiple regression. Xt can be a big vector of systemic risk measures. So what I'll do is I'll run this regression. This regression works a lot like OLS, except it has a different loss function. OLS's loss function is this blue curve here. What it tries to do is minimize deviations from the model. And the penalty that it places on those deviations is very large. It's quadratic if you get far away from the accurate prediction. And it's symmetric. The penalty is large on both sides. What's the difference between OLS and median regression? Well, they're just different penalty functions. Median regression is this green V-shaped penalty function. So it places more weight on kind of your typical outcomes, things that are close to the median. And it doesn't penalize as much as OLS when you get far away here. What's the nice generality of quantile regression? Is that I can effectively choose the shape of that penalty function. If, for example, I want to emphasize the lower tail of the distribution, suppose I want to do a 20th percentile quantile regression. What I can do is use a loss function that looks like this red function. So what this is going to do, it's really going to highly penalize errors that are made in prediction that occur in this part of the distribution. It's not going to pay a whole lot of attention to what's going on out here. So what the estimate does is it forces you to focus on the particular part of the distribution that you've told it to focus on. Which is why when we end up with our estimates, we can say that this linear form is going to be the best description of the quantile that we've asked it to describe using some linear relationship based on the systemic risk measures. So those are going to be the form that all of our measurement take. I'm going to run a bunch of regressions that look like these quantile regressions, and we'll be looking through those results. All right, so to give you a sense of how this works, here is one particular systemic risk measure that I described, absorption ratio. Think of it as a measure of the correlation among bank equity returns. I'm going to run regressions at different quantiles. So the thick purple line, that's the 20th percentile regression, and I increase all the way up to this thin purple line, which is the 80th percentile regression. Here's a situation in which quantile regression is not very useful. Because as I change the quantile, the relationship across the systemic risk measure and how it relates to economic activity, it has the same slope. This is a situation in which OLS would do really well, because the distribution really just looks like a mean shift. All right, compare this to another systemic risk measure, one that we think is a good one. And this is what the quantile regression gets you. So, the systemic risk measure that we're looking here is a measure of financial sector equity volatility. We're looking at the same economic outcome. But what you see here is that when this systemic risk measure gets really high, the distribution of outcomes widens out dramatically. This is where quantile regression is very useful. If I'm trying to describe the 20th percentile, so these very bad outcomes, we see this steep negative relationship. But if I'm trying to think about what goes on the upside of the distribution, it's actually a fairly flat relationship. In fact, there's a nice way to read the conditional distribution of the outcome right off of this graph. Pick the level of systemic risk that you want to be thinking about. Say turbulence equals 4.2. And think of a curve coming off towards you from the slide here. I can overlay that distribution, and each of these points on this vertical line is going to tell me where the 80th percentile is, the 60th percentile, the median, all the way down to the 20th percentile. So by looking at this vertical slice of the graph, I can just read off the conditional distribution for economic activity, given that systemic risk is at 4.2. Now, if I go to systemic risk being 5.6, I can do the same thing. Now, if I read off the conditional distribution, it does look like the distribution is shifted downward, but more importantly, it looks like the distribution is stretched a lot on the downside. Okay, so that's where we're going to get some mileage out of quantile regression. Okay, so what are the variables that we're going to be using to quantify macroeconomic outcomes? So we're going to focus on two for this talk. First, I'm going to think about industrial production. And second, I'm going to think about the Chicago Fed National Activity Index. Okay, so think of this as just some composite indicator of overall economic real activity. I'm going to convert each of these series into shocks. Okay, so I'm going to use a time series model to build growth rates that are shocks. Think of them as just innovations to an autoregression. And those shocks are the things that I'm trying to forecast. Why am I converting them to shocks? Because I want to make sure that if I do detect some predictive relationship between a systemic risk measure and the shock, it's not coming from own history and say industrial production growth or the own history of the CFNAI. It's well known that you can get some spurious results if you don't use shocks in these types of regressions. So by constructing these shocks, I'll be fairly confident that if I do find a relationship there, it's genuine. So what does the data that we have look like? In the US, we have a lot of data. We have IP growth. We're going to look at the post-war sample. We have the Chicago Fed National Activity Index. That starts in 1967. We're going to build the same stuff for the UK, but we have less data there. So our data for the UK and for the EU are going to come from the OECD, and most of that data, I believe, starts around the 70s or 80s. Okay, so we're going to estimate quantile regressions like this. For the most part, I'm going to focus on the 20th percentile. So I'm going to focus on a relatively downside outcome. We don't want to go too far into the tail distribution, because then we have measurement issues with lack of data. We don't want to go too close to the median because we think we might not be seeing effects there. So we think of sort of the 20th percentile as a happy median. All right, we're going to do all of our tests out of sample. We want to be thinking of this as forecast useful evaluation that policymakers could be doing in real time. All right, and we're going to report things like quantile R-squareds. They are really the direct analog to OLS R-squareds, but they're just calculated a little bit differently. Okay. So here are the results looking at the 20th percentile of IP shock forecasts. 1 quarter ahead, using IP growth in the US. These are different sample splits for the US. And this is for the sample splits that we have, for the samples that we have in the UK and EU. These are each of the individual systemic risk measures that I listed on the slide that we have to look at. So these are out of sample R-squareds that I'm reporting. These are the quantile R-squareds. And you see a lot of negative R-squareds up here. What does that mean? Well, in sample, of course, R-squareds can't be negative. But once you go out of sample, you can very well have a negative R-squared. Because what the R-squared is doing is comparing the fit from the model to a fit based on a naive forecast. And the naive forecast that we have here is just the rolling historical 20th percentile for each of the series. So think of this minus 2.8% R squared. That says that the absorption ratio does 2.8% worse out of sample than if I were to try to forecast the 20th percentile just using the historical 20th percentile. All right, so where do we see some numbers that are not negative? Liquidity looks like it does a reasonably good job, at least in the US. See, the default spread doesn't do too poorly. And we start to see that financial volatility measured as volatility and financial volatility measured as this turbulence measure seems to do really well. So these stars are, of course, 10, 5, and 1% statistical significance. Okay, so volatility and turbulence, we get here some improvement over the historical quantile in all samples in the US and internationally. Turbulence works extremely well in the US, it doesn't do so well internationally. So what we'll see as I go through some of these tables is that volatility and turbulence kind of consistently show up as useful predictors of macro outcomes, while the other variables are very inconsistent. Okay, so here I'm going to change the outcome of interest, the 20th percentile now of the CFNAI shock. Okay, just another measure of economic activity. What do we have here? Well, some of the other measures that looked useful before, like illiquidity or the default spread, no longer appear useful according to this measure. However, volatility still looks like it's doing pretty good. It produces most of the time positive R squareds. Market leverage actually looks reasonably useful, and turbulence looks fantastic. This measure of financial volatility is especially powerful for this data set. Okay, so broad conclusions from the individual predictors. At best, there are a couple of exceptions that seem to do well. Those exceptions seem to be characterized as measures of financial sector volatility. The question is this lack of predictive ability throughout the table, is that because the measures don't contain information, or because they're just poorly measured? I expect them to be poorly measured. Systemic risk is like a notion of tail risk. Tail risk is really hard to measure. So the question is, if there's something useful in there, how can we tease that out? All right. So in order to do that, we're going to use some statistical techniques that we've proposed specifically for this problem. And we took the cue for how to do this from the way people have been thinking about forecasting in macro for a long time. But most of that literature is about least squares forecasting. We're going to do very similar things, but in the quantile forecasting approach. All right. So I'm going to propose two new methodologies. One is going to be called principal component quantile regression, and the other one is going to be called partial quantile regression. You may have not heard of partial least squares. I've done quite a bit of work with partial least squares in the past. Quantile regression, partial quantile regression is going to be the analog to that. Another thing that we can, of course, try to do is do multiple quantile regression. All of the results that I showed you, they were univariate regressions. I was using one predictor variable at a time and seeing how it worked. Alternatively, I could have put a whole bunch of different systemic risk measures on the right-hand side jointly and saw how that did. It turns out that that works extremely poorly. You'll see that in a second. But we kind of knew ahead of time it was going to work extremely poorly because we have a big increase in the incidental parameters that we have to estimate. All of those quantile regression coefficients, they eat up degrees of freedom. And we don't have very long time series to begin with. So that can be very painful when we move out of sample. In sample, it'll work beautifully, of course, because we'll be overfitting the data. But out of sample, multiple quantile regression cannot work so well. Okay, so we're going to find that these two versions of dimension reduction techniques have some nice properties. So let me set up the problem. This is how I want to think about it. I want to think about there being a true systemic risk factor, F. To describe the quantiles of the macroeconomy, I would need to be able to observe F directly. We don't get to observe F directly. It's the true systemic risk, and at best we can just measure it from data. So what I do is I go to the data and I build systemic risk measures. Suppose I build financial sector volatility. Financial sector volatility has some information about F in it. But it has also information about other stuff, which I'm going to call G. Think, for example, about that other stuff being the high volatility that was associated with tech innovation during the tech boom. And then it also has noise, purely measurement error. The question is, how can I make use of a series like this when I know that the quantile is going to be specifically related to systemic risk? Well, the idea is going to be to look at a whole bunch of different X's and aggregate them together. So one easy way to think about this is, suppose I just took an equal weighted average of all of the x's. What would be a benefit of doing that? Well, if I really think that this epsilon is pure noise, a law of large numbers would kick in and it would kill that noise. So that would be a good starting point. Just average your systemic risk measures if you think there's measurement error. The issue is that I wouldn't get rid of these pervasive variables that drive the different systemic risk measures, but that aren't about systemic risk. They're just about other pervasive macroeconomic quantities. So what I want to do is come up with some clever way of using this information that gets rid of the epsilon and somehow allows me to focus on the F part without paying attention to the G part. The F part is the systemic risk factor that I really want to capture. Okay, so here are two ways of doing this. The first is PCQR, Principal Components Quantile Regression. So you can imagine how this would be a natural place to start. Take all of your systemic risk measures and calculate principal components. Turns out they have a small number of factors that you could extract as principal components, and they describe a vast majority of the variation in the panel of systemic risk measures. Now take those systemic risk indices that you've constructed via principal components and use those to forecast. That's going to have some nice features in that by the nature of principal components, it's going to eliminate this epsilon part. But it's not going to allow us, unfortunately, to disentangle the F, which we think is the systemic risk factor, and the G, which are other pervasive macroeconomic factors that are not about systemic risk. Nonetheless, we can estimate these. We can take these principal component factors and we can use them to forecast. So that's one approach that we'll do. We'll just plug them into the quantile regression as though they were just another systemic risk measure. The alternative that we like a little bit better is called partial quantile regression. And this is a very intuitive way to proceed. It works as follows. First, I'm going to go through predictor by predictor and try and forecast IP growth. That's going to give me a predictive quantile regression coefficient beta. What beta tells me is how strong of a predictor is particular predictor I for forecasting IP growth. A high beta means it's a strong predictor. I'm going to do this for each individual predictor. I'm going to get a set of betas. I'm now going to construct a weighted average of those predictors where the weights are the betas. So that'll put a lot of weight on the ones that I've measured to be strong predictors, and it'll put less weight on the ones that I've predicted to be weak predictors. All right, so when I put these together, what do I get out of that? Well, first, I still get the law of large numbers kicking in and killing the epsilons. But because I'm weighting things based on their ability to predict the thing that I care about, I'm actually going to be able to isolate the F component and drop the G component. So we have a lot of math in the paper that shows exactly how that works. It's a fairly well-known phenomenon in the least squares setting. It turns out to also work in the quantile regression setting. So for predictive problems like this, my co-author Seth Pruitt and I have argued a lot that partial least squares, and in this setting, partial quantile regression, ends up getting around a lot of the forecasting problems that people have effectively been running into throughout the macro literature. We've showed it in some other papers, and now we're going to see it in the systemic risk setting. Okay, so we're going to end up with a factor, F hat, that exactly is built to measure systemic risk. It's exactly built to do a good job of forecasting the lower tail of the macroeconomic distribution. How am I on time?
5 minutes.
Okay. All right, so let's look at some of these results. All right, so I'm not going to show you the full table. I'm going to show you the results based on these dimension reduction techniques. So I'll look out of sample again at the 20th percentile. I'm going to look at industrial production. And I'm going to look at CFNAI. And here are the different dimension reduction techniques I'll consider. First, this is multiple quantile regression. This is when I just take 17 systemic risk measures and put them all as separate right-hand side variables and estimate a coefficient on each. Works great in sample, but gets crushed out of sample. How about when I do the dimension reduction technique? If I pull out the first principal component or the first two principal components, it turns out to do a pretty good job forecasting macroeconomic outcomes. Now, a more parsimonious way to do this, rather than say pulling out two principal components, is just to pull out one systemic risk factor in a sort of a more clever, a more pointed way via partial quantile regression. If you do that, we see good and actually significant quantile predictability throughout all of the samples that we look at. The same thing shows up in the Chicago Fed Index. So PCQR now looks a little bit weaker, but PQR, partial quantile regression, continues to do substantially better than, say, a naive forecast. Okay, we can look at other quantiles. So for example, I could look at the 10th percentile rather than the 20th percentile. So I go a little bit further into detail. We see the same type of result. But now I want to see what else I can learn from this information. Being that I'm running out of time, I want to focus on some other stuff. Okay, suppose I tried to do the exact same thing, but just focused on the median, just focused on the center of the distribution. Is there something special about the tail? So I'll do quantile regression for the 50th percentile as opposed to the 20th percentile. And I want to compare the results to what I just showed you. All right, so first of all, regardless of effectively the measure I use, you get a little something from turbulence. But even for these systemic risk indices, it doesn't look like any of these systemic risk measures are good at forecasting median outcomes. But I can compare these coefficients. So these are going to be the estimated coefficient in the median regression. This is the estimated coefficient in the 20th percentile regression, and this is the difference between the two. What these negative signs tell you is that there's a stronger effect in predicting downside risk than there is at predicting median risk. Okay? In all cases, when systemic risk goes up, the sign tends to be negative. But it's much stronger when you're predicting the 20th percentile. Here's the t-stat for the difference. It's interesting. It's not just for our preferred measure that this works. For all of the individual measures even, you see that the individual measures are more informative about downside risk than central risk. Okay, so how did policy behave during these episodes? Now I'm going to look at things that look just like what we did, but I'm going to have a different variable that I'm going to forecast. It's going to be changes in the Fed funds rate. So what we see is, again, these are going to be forecasting R squareds. Our measures of volatility do very well for predicting large decreases in the Fed funds rate, and don't do a whole lot for predicting the median. So it looks like when systemic risk rises, and it looks like things are especially severe, that's when policymakers respond. All right. Now I want to look at the special role of financial volatility. In all of these predictions, I've been using financial volatility. But is that about financial volatility per se, or is it just about volatility in a broader sense? So I'm going to look at that specifically. I'm going to break volatility into two pieces: financial sector volatility and non-financial sector volatility. I'm going to see if we get anything similar if we just use stuff that goes on in the non-financial firms. So what we see is that all of the forecast power for the 20th percentile of IP growth comes from financial volatility. There's no predictive component based on the volatility of non-financial firms. I think this has some really important macroeconomic consequences, because now there's a big literature in macro that looks at so-called uncertainty shocks. What they literally do is they use the volatility of the S&P 500 to try and forecast growth rates of a bunch of different macroeconomic variables. But what this suggests is that it's not about the volatility of the entire economy. It's about the volatility of the financial sector. So I want to look at that directly. Okay, so the paper that really got this literature going was a paper in Econometrica by Nick Bloom in 2009. And he ran some impulse response functions. He basically put together a VAR where he's trying to forecast some economic outcomes in that VAR. And within the VAR, he included volatility of the economy as a whole, measured, say, via the S&P 500 index. And what he found was that when there was a big spike in volatility, output dropped, production dropped. So these are deviations from trend. It looked like this drop really peaked about 6 months out and eventually recovered. But the question is this about S&P 500 volatility? So what we do is we take this exact same VAR and we modify it a little bit. We include two components of the VAR. We include aggregate volatility, just like Bloom did. But right below that, we include financial sector volatility. So these things are imperfectly correlated, and by considering the impulse responses to each, we can see really where the effect on output is coming from. Here are the results. So this is the new impulse response for aggregate volatility if I also control for financial volatility. It doesn't look like there's any significant effect at all. You can still see the dip, but the magnitude is small and it's insignificant. However, financial sector volatility is now picking up all of the transition. The spike in volatility that really matters for outcomes is the spike in financial sector volatility. It's not about what happens to Cat Tractor or 3M. Okay, so I'll wrap up with that. What we want to do is get people thinking about what are the empirically relevant features of systemic risk that we think we should be paying attention to, and in particular, policymakers should be paying attention to. So we argue that one way to think about this is to try and link measured systemic risk to actual fundamental outcomes on the real side of the economy as opposed to the financial side. So we propose a way to do this via quantile regression, and the main stylized facts are that the systemic risk measures that we've constructed, they are useful. It's hard to see the usefulness of them individually, but you do see it when you aggregate them in an appropriate way. And what's interesting is that they're not just related to macro outcomes, they're very specifically related to downside outcomes, downside macro risk. You can see some responses by policy, but the fact that we pick up anything in the macroeconomic outcomes suggests that the policy response is not strong enough. Even after the policy response, we're still seeing an association between systemic risk and the macroeconomy. It would be a really interesting question for the PhD students in the room to try and get a handle on what would the outcomes look like, what would the counterfactual be, what would outcomes look like had policy not responded at all. I would suspect that they probably would have been substantially worse, but that's a measurement issue that we don't try and tackle here. And lastly, there's a very special role for financial sector volatility as a measure of systemic risk and in terms of understanding downside outcomes in the macroeconomy. It's distinct from the notions of volatility that people have looked at in the macro literature in the past. Thanks a lot.
Thank you. First discussant is Adam from SEC.
Thank you all for inviting me to discuss this paper. I haven't met a lot of you. My name is Adam Yonce. I'm at the Securities and Exchange Commission. I'm in the Financial Intermediaries Group. And so, as you've seen many times the past 2 days, the standard disclaimer applies. These are my views only, not the views of my colleagues who are here or the Commission. What I want to discuss about this paper, Bryan already went through his research questions quite well on this, so I'll just kind of briefly touch on what the research questions are. There's a whole catalog of systemic risk measures out there. Various authors have proposed them. Their goal is to take this whole catalog of systemic risk measures and evaluate them. And then figure out how to discriminate between these measures, figure out which ones work, which ones have information about the real economy, which ones don't. And then, as he discussed how these measures are very noisy, trying to figure out, is there some useful information we can extract, a common component that forecasts macroeconomic shocks and can be useful for policymakers. So those are the research questions. The contribution here is they do demonstrate that there's this latent factor, this PQR, the factor extracted from the partial quantile regression, that contains information about the left tail of industrial production and the Chicago Fed index. They also show that the systemic risk indexes forecast changes in the federal funds rate. So either explicitly or implicitly, policymakers are responding to these indexes. And then there's a technical contribution here, deriving the principal components and partial quantile regression estimators, improving their consistency. I think that's very useful, particularly as more finance research is focusing on estimating tails of distributions. And one thing I didn't really appreciate from reading the paper, but I appreciate more now after hearing Bryan talk, is how a lot of these measures seem to have a lot more information about tails than medians or means, and I think that's really useful. One of the things that we're learning is that this link between the nominal or financial economy and the real economy is a nonlinear one, and so I think this is going to be really useful going forward. All right, so some comments on the empirical results. I think my interpretation or my view of the paper, I think, is going to be slightly different from Bryan's. I think it's a very nicely done paper. I think when I was reading it, one of the things that was screaming out to me is that a lot of these measures, while they work really great in sample, just don't look good out of sample. I think there's a lot of, when you look at table 5, there's a lot of seeming randomness to the results. Some measures that work for the United States, but not consistent across the time horizon. Some measures that work well for the UK and Europe. What you would really like to see, I think, is some consistent forecastability across samples, across countries. And you really only see that with things like the default spread or volatility, or this CATFIN variable, which is in the most recent version of the paper, which is, I think it's like a value at risk for the financial sector, right? So it's related to these volatility measures. Again, it's things like leverage and volatility and spreads and these aggregate financial market pricing measures that we're all familiar with that seem to work really well. Whereas a lot of the systemic risk measures that have been proposed since the financial crisis, like this COVAR and marginal expected shortfall, don't really seem to have a lot of forecasting ability out of sample. Another interesting thing is that this COVAR seems to work pretty well in the UK and European Union, but not in the US. That's something I think that's a bit of a head scratcher. I think that Bryan and his co-authors, I'll just get to this next slide, I think they are admirably agnostic about these individual measures, and I think they do a very good job of saying, yes, there is information to extract from these measures, and really trying to resurrect them, really trying to resurrect the information in these measures as systemic risk measures. I'd actually like to see them take a little bit more of a stand on these individual measures, ask more questions about their inability to forecast much of anything or the seeming randomness of the measures. That said, hearing Bryan talk about the noise and the measurement error, I think I have a much larger appreciation for the measurement error and the difficulty that brings. I didn't really appreciate so much that point when reading the paper, but I think I appreciate it now, so perhaps I would walk back a little bit back. But I guess the main difference in interpretation is that they really want to they do a very good job of trying to resurrect these measures. And I just see kind of noise and randomness in Table 5 and Table 7. My own interpretation. So some questions that I had when reading through the paper: is the macroeconomic shock the right benchmark? I think the experience of 2008 says yes, it has to be a benchmark, this link between the financial economy and the real economy, but is it the only benchmark? I'll talk about this in a little bit. Not all recessions are systemic, not the left tail, this 20% left tail, it can't all be driven by systemic risk. So that's one thing I wonder about. Are we, this forecastability, are we going to, are there going to be false positives here? Are we going to ascribe it to systemic risk when it's really something else? 2008, the failure of COVAR, marginal expected shortfall, they work really well in sample, but they don't work so well out of sample. It suggests to me that these measures were designed to explain 2008. Should we be worried that variables that forecast the left tail are not necessarily associated with systemic risk? So what I mean by this is that the measures that seem to work really well are volatility, leverage, things like spreads, financial market indicators that have been around for a long time and people haven't necessarily thought of them as systemic risk measures. I think there's a lot of alternative hypotheses for why these measures might be linked to the real economy and why they might forecast the left tail of macroeconomic outcomes. They're not all necessarily linked to systemic risk. So those are some questions I have. I'll go into a little more detail. One thing about this latent factor that they extract. One thing that I'd like to see is, we know this from principal components analysis, a lot of times these hidden factors that we extract, they lose economic meaning. And so I think it would be really useful for the paper to show some loadings, show some essentially factor loadings. My analogy is in asset pricing where you'll sort your portfolios and then they extract principal components, and a lot of times the first principal component is just the cross-sectional average, and the second one is the highest return portfolio minus the lowest return portfolio. I'd like to see some factor loadings here, particularly because I'm wondering if they're loading mainly on these volatility measures that we already know work pretty well. I think that would be useful for the paper. So the real economy benchmark, I talked about this a little bit before already, but not all recessions are driven by systemic events. I think with using a 20% left tail and seeing that a lot of the variables that work are these volatility measures, I think the danger of false positives is high. When is the right time? I'm getting into sort of the regulatory and policy question here, but when is the right time to use systemic risk regulatory tools? And again, what I said before, there's lots of alternative hypotheses for why volatility or the default spread or the term spread may forecast real macroeconomic shocks. And so I think we want to be careful about using results like these because I think the potential for false positives is quite high. Also, thinking about alternative benchmarks, this is a tricky one. I agree completely that there has to be a macroeconomic benchmark, but I'm wondering if there are some benchmarks that we can use. When I think of systemic risk, one of the things I think about is this notion that financial intermediation is breaking down. That the supply of credit shrinks and that financial intermediation really falls apart. So is there maybe some measure of the quantity of intermediated assets out there that we can look at? I know Thomas Philippon at NYU has written a couple papers on how to measure the quantity of intermediated assets, so that might be something useful to look at. And then finally, so this idea of macroprudential or macro regulation versus institutional regulation. Maybe it's not quite right to say this paper is macroprudential, but it has a macro flavor in the sense that do these measures of aggregate financial sector distress forecast the left tail of these macroeconomic variables. As regulators, I think one of the things we really care about is institutions. We care about the sources of systemic risk, which institutions are systemically important, not just what is the overall level of systemic risk. It's a bit tricky because I think these institution-specific measures are going to be noisier than the aggregate measures, but I think that's something to think about here as well. And he's telling me I'm done, so I'm just going to conclude. I learned quite a bit from this paper. I like the technical contribution and some additional questions to explore are these links between systemic risk and intermediation, the quantity of intermediation, and why is it really that these volatility measures are the ones that seem to work well, and the measures that were designed to actually measure systemic risk don't. So I'll leave it there. Thank you.
Our second discussant is Fernando from New York.
Right, thank you very much. I'm very happy to be here. Thank you for inviting me to discuss. I also have the usual disclaimer. I'm from the New York Fed, so I'm not going to tell you when rates are going up or anything like that, and if I do, it's my own view. So the bottom line of my discussion is a fantastic paper. I love it. I've been following this paper ever since Bryan presented it at the New York Fed. I've read a few versions of it. The last version is really polished, really easy to read. I really recommend you go and read it if you haven't. I think it's going to become standard. Basically, every time someone comes up with a new systemic risk measure, they're going to have to at least show how it works in that framework. Show that it adds information to the PQR, the PCQR, run the Quantile regression. In fact, I'm going to show you one systemic risk measure that I constructed and how it performs with this. So this is an example I think, where the literature is going. It's going towards using this. And that's fantastic. I was happy to see that risk measures are useful, okay? That there's all this human capital being devoted to it. And as Bryan said, it's an explosion of measures. And you know what? Hey, they work. They give us some predictability. They don't work for the median as well. They work for the tail. They do a lot of things that they were designed to do. So good job, research. You know, it's great. The one thing that was really striking, simple is simple better, volatility, simple volatility of financial sector assets, banks. It works really well. It works really well. That's the simplest model. It has no model, it has no, nothing crazy behind it, and it works really, really well. So that's really intriguing for me. One thing is, yeah, we need a model maybe to explain why. The other thing is, well, a lot of institutional, and this is for the policymakers, a lot of institutional details and market structures have been changing over time. Volatility could be the one constant that is always there. But if we think of certain measures like COVAR that didn't work so well before but work much better now, yes, maybe it's this post hoc bias of having been constructed to explain the crisis, but maybe it's just that some markets changed and certain measures work better now than worked before. And I think that's going to be the case, for example, in one of the versions of my measure where we look at the repo market, which was not as big a deal in the 90s and pretty much non-existent in the 70s. And that would not show up as a really good predictor over the whole sample, but we know as policymakers that that's a key part of the financial system today. So I want to also encourage policymakers to think carefully about what's the structural reason for using the measures. Nevertheless, volatility of financial assets, of financial stocks, that's amazing. And then the important caveat to keep in mind, and I don't think Bryan can do anything about this, or anyone. If anyone can figure this problem out, that would be like a paradigm shift. But yes, there is the policy intervention that perhaps prevents some of the systemic risk to get realized into negative economic outcomes. And how to tease that out is very hard. On the other hand, we see still some predictability, meaning there's still some systemic risk that predicts bad outcomes of the macroeconomy. But then there we also have to think, well, maybe there's an optimal level of fragility. Maybe we don't want to eliminate all of the systemic risk. So there's tricky questions there, but this is more for the policymaker looking at the results and not a comment on the results themselves. Okay, having said all the really, really good things about the paper, let me talk about a couple of things that I want to ask about. This is a similar comment to Adam's. Can we identify the principal components? In the PCQ, the partial quantile regression, we do have the weights. They are the individual coefficients of the univariate regressions we use, each systemic risk measure at a time, so that's very informative. What about for the PC? Yeah, I would like to see the weights, and also maybe if we can try to correlate them or to identify them to some specific economic variable. Like Bryan talked about the Stock and Watson work. There you have a billion variables, you aggregate them into a few factors. The first factor is industrial production, and that's very clear. So can we do something like that here, where we can say, oh, it's volatility, or it's something else, or it's something we can then put our fingers on and then use it. The other question is, I was really intrigued by this GT. So GT, if you remember, were things that affected the systemic risk measures, but did not affect the conditional quantile of the distribution of the macro outcomes. And Bryan gave some examples. I don't know if it's possible. I know for the principal components you can't disentangle it, but you can for the PCQ. Maybe comparing those two can tell you a lot about G. What does it look like? Can we identify that? And then there's some assumptions that go into G in order to make this disentangling possible in the PCQ, like the distribution has to be symmetric and so on. So it's a very important contribution what they do. I just want to understand when would it not work? Just an example or two in the paper, or or maybe in the presentation, just saying, this is a plausible scenario in which this estimator will fail. We know when it works really well, the assumptions are very clearly spelled out. That's just to know as a policymaker, what are the scenarios that I need to think about that are not in the framework necessarily. Another question is, can we control for policy? I mean, we've been making this case that policy affects the outcomes of the macroeconomy. It might affect the systemic risk measures. Can we just put one or two measures of policy in the quantile regression and then say, well, the remaining effect is the effect of the systemic risk measure if you take away the policy? Maybe put it in the quantile principal component, I don't know. Think about, is there any way to at least reduce a little bit this idea that policy eliminates some of the systemic risk measure? I was going to say dancing with the stars, but then I thought, oh, that's going to be too bad, too cheesy. So I said, follow the stars. Still not good, but you know. I was shocked. Turbulence and CAT-FIN, this new measure that's the VAR of the financial sector, they work great. Sometimes in a lot of tables, they actually work better than the PQR. Not in all of them, and theoretically, I understand the PQR is much more desirable. It eliminates the noise. But here, yeah, you start to wonder, maybe some of the measures are better off being left apart. And I know in a paper that's not what you should do, but I can say some discussant. So I was intrigued by that. I was intrigued by how superior some measures were. And then the last point that I will also address when I look at my results on my own systemic risk measure is the one about horizons for prediction. So here we're doing 1 quarter ahead prediction, and I understand that the longer the horizon you try to consider, the harder the predictability gets, the bigger the noise probably. But I think looking at longer horizons is very important. Why? Because systemic risk is not something, in my mind, that necessarily occurs quarter to quarter. It's something that builds up. It's fragility. It takes a while for fragility to build up. Leverage increases, maybe house prices go up, you're getting all these vulnerabilities into the financial system and the economy, and then one day something happens and this vulnerability gets realized. So maybe looking at predictability over 6 months, 1 year, 5 years, I don't know what you can achieve, can give us that. And I'll show you how that works in our measure. So this measure that I constructed with my colleague Thomas Eisenbach at the New York Fed is a measure of vulnerability to fire sale externalities. So here the idea is, imagine a negative shock hits the financial system. Now all banks need to delever. They're going to sell assets, and then the price of those assets is going to go down. And whoever else in the system, whether those same banks or anyone else who's holding those assets that got fire sold, are going to take losses in their balance sheets. Okay? So that's a pure externality. So what our measure does is it figures out how big those externalities would be if a shock hit the system. And here we deviate from a lot of the measures in the survey of Andrew Law and that Bryan uses, because we use detailed balance sheet information. So we don't use asset prices as much. We use mostly detailed balance sheet information. And I will show you some benefits of that when we go to the graph. We also construct a version using repo market assets. And this is the first systemic risk measure in the repo market. And we feel like, yes, this is specific to the last crisis, but that's because in previous crisis there was no repo market that was well developed. And we know that was ground zero for the crisis, so it's really important to have a systemic risk measure for the repo market. So this is the first one to do it. And it's very related to the GC measure that Bryan uses. Basically, we're one step behind. So broker-dealers play a huge role in the repo market, and they also play a huge role financing corporate debt. The GC measure looks at that corporate debt broker-dealer connection. We look at the repo market broker-dealer connection. Okay, so here's the measure. We can only go to 96 because of data limitations, and perhaps that's not enough to include it in a survey, but perhaps it is. I mean, for the UK and the EU, that's the range of data that Bryan has. And this is what I'm talking about. So if you look throughout the 90s, this measure was roughly constant, but then starting in 02, or perhaps if you want 03, this measure just starts building up, building up, building up. So this increase here is the build-up in fragility that I think is what you get when you look at balance sheet information. You do not get that from prices. So right before the crisis, you know, or like in 06, 05, 06, beginning of 07, you have low volatility, risk premium are compressed. All the market measures usually tell you, oh, things are great, volatility is low, you know, we're all good. In fact, if you remember the graph that Bryan showed of all the systemic risk measures, almost all of them in 05 were low. Whereas our measure by 05 is already signaling, you know, pretty bad stuff is going to happen. Okay? And then what we did is we ran exactly the same regressions that Bryan did. So these are the R-squares from individual single-variate regressions. And here we show different measures. Our measure is called aggregate vulnerability. And we do the 3-month ahead, which is the same thing that Bryan did. And here, for example, aggregate vulnerability.
Which variable?
Sorry?
Which variable are you forecasting?
Industrial production shocks. So same, take industrial production, do the autoregressive. So this is IP shocks. 3 months ahead, aggregate vulnerability does not do very well. In essence, you know, if you're trying to forecast throughout this region, we're saying, oh, bad stuff's going to happen, bad stuff's going to happen, but that just keeps not happening. That's the build-up. But 1 year ahead, we do much better. I think we're the third best measure overall. Look at the head spread though, fantastic all throughout. This is from 96, that's why results are a bit different. And this is in sample just because the data, we don't have much data, but out of sample looks similar. And then the other interesting part of this table is, look, at short horizons, you have some clustering of what measures do well. The ones that do well at short horizons don't do well at long, and kind of vice versa. There's a cluster that does better at long horizon that doesn't do well at short. So maybe that's another interesting dimension to think about. And finally, you can always include or exclude a variable from your PQR and PCQR and see if it adds information compared to the existing ones. And here, I'll stop, but just to show you a methodological way to do it, and that our measure adds a little bit of information, especially at the longer horizons. Right, thank you so much. Now we can get lunch.
Why do you want to take a few minutes to respond and take a few questions?
I want to get lunch.
Thank you to both discussants. Very interesting comments, and I don't have much to respond to. Although I would like to address Adam's a little bit. So I think it's a very important question. Are low quantiles of macroeconomic outcomes about systemic risk per se? And the answer is surely not only about systemic risk. But I also want to be very clear on what our objectives are with this paper. I'm trying to think of it as trying to fill out the empirical landscape, because we really just don't know anything about what these measures are and what they do. So that's all we're trying to do. We need a starting point. I think a good place to think about systemic risk, you don't want to think about the center of the distribution of macroeconomic outcomes when you're thinking about systemic risk. You want to think about the tail. So I think that's a good place to start. And now we're just have some empirical evidence out there. I kind of view it as some of the earliest empirical evidence that we can work off of. And now, great, the field can go and kind of hash out additional details. But otherwise, I appreciate a lot of these comments. Some of them are going to be very useful in a revision I'm working on.
A couple of quick questions. How many dimensions, I didn't see this in either the paper or your presentation, how many dimensions of these measures when you do the principal components?
Yeah, so you probably need about 4 principal components to get to roughly 98% of the
And on the left-hand side variables, how correlated are they? And have you thought about a dimensional, policymakers care about industrial production going up or down, shock to the peso,
Right.
and something else happening, not alone.
Yeah, that's
So if you
great.
talk about relationships there.
It's a great question. So one thing is that, actually Fernando alluded to this, is, IP is sort of like the first principal component of the macroeconomy. So in some sense we are doing that, but we go into more detail in the paper. So this Chicago Fed Index, it's a
It's like
composite.
6 or 7
It has,
indices.
I think, 300 variables or something going into it. And then they provide sub-indices. And in the paper, we analyze each of the sub-indices. So they have 5 different sub-indices. Some are about consumption, some are about productivity, some are about other household stuff. So employment. So we look at each of them individually in the paper.
But I was thinking of looking at them together.
Right. So I think by having both, by looking at the composite CFNAI, and then each of the subcomponents separately, we're trying to hit both of these.
I'm just trying to understand how the quantile regression kills this G. Is there an assumption that things are nonlinear in F and not nonlinear in G?
Okay, so that's a good question. So the person I'm expecting to get that question from. So we can think about it quickly in the PLS setting. So you need some identifying assumption that's going to separate the F and G. All right. So and you can generally use these identifying assumptions since the factors are latent, so we can't do it anyway. So we're making an identifying assumption that the covariance matrix between those two is zero, has 0 off diagonal elements. All right. So once you make that assumption, you're taking. So maybe there's stuff in, say, I don't know, unemployment, which we would think would be a pervasive factor, that has a systemic risk portion to it. We just allocate that all to F. And then all the non-systemic risk G stuff, we're going to be able to avoid via the PLS approach, the PQR approach.
Curious whether you address in the paper your long-run measures and how firm composition or data quality could affect your forecasting success. So some of these very long horizons, the composition of the firms that you're measuring does not really change over time. And also, I suspect that the accounting variables when you change actually how they're
Absolutely.
measured over time as opposed to the market measures, and is that why you're more successful with your market measures?
So, we look at a long time series. In the US, we're all post-war. We expect there's going to be a lot of structural change in the sample, right? And it can be structural change in terms of reporting. It can be structural change in terms of composition. And all of these things we just sort of have to gloss over. So a couple things that we do to address this is when I'm building these measures, I'm actually doing it in a rolling window using the 100 largest financial institutions at each point in time. So that's one way that I try to address things like entry and other kinds of things. And we really don't have a whole lot of fundamental variables and balance sheet variables that go into this. They really only show up in the leverage measures, mostly because people that have studied systemic risk in the past have also relied on the equity market to tell us about things. And I think once you're relying on the equity market, you face one of the issues that Fernando brought up, which is so important, which is trying to identify the buildup. You're not going to see the buildup very well by looking at the equity market, because the equity market's going to respond once things start going in the tank, and not very much before. Which is why I think those measures do so well in short-run predictability, but not in long-run predictability. So having access, I would love to have access to some of this data, and I'm looking forward to see what you've done, because it is exactly what we would ideally be doing, including those types of measures as well that have the multiple frequencies that probably exist in systemic risk all being captured by our index.
If not, let's take a break and head out for lunch.